We've heard from 3 customers. I'm going to get each of the additional panelists, each of these speakers has something to do with delivering the technical side of this or driving the standard. So we'll start with John Dyke, who is the CEO of SESME, and he'll talk about, because I think, who else is aligned with SESME? You are. So there's a lot of SESME interaction here. So I asked John just to spend a minute or two, for those that don't know SESME, explaining what they're trying to do and how it ties into data fabrics.
Thank you, Colin. So it's a privilege to be here. I think we've got 3 slides set up. While that's happening, my name is John Dyke, the Chief Executive Officer of SESME. We're a consortia funded by the federal government to advance the adoption, to accelerate the adoption of smart manufacturing here in the US. So we get to convene what we believe are some of the brightest thinkers and thought leaders in this space from the manufacturing community, from the machine builder community, from the technology provider community, academia, and systems integrators, consultants, and work together to identify the issues, the challenges that we face as a manufacturing nation, and specifically through the lens of smart manufacturing, how can we fund removing the headwinds, or at least working on making smart manufacturing less complex and less costly for this entire community. And so we've been given about $200 million to do that, and our approach is to, as I said, bring this stakeholder group, this community together, identify the problems we need to solve, and then spend the money to solve the problem, to refine, to take what we've learned, refine it, and then bring it back into the community. So the topic at hand today is about industrial data fabrics. We have a significant, we split almost evenly between our focus on the business and the culture and the learning side of smart manufacturing. How can we bring all of the sort of knowledge, raise the knowledge of smart manufacturing from the kind of executive level all the way to the talent pipeline, and everywhere in between, the practitioners and everywhere in between. How can we raise the knowledge of this community? We've got tools and business assessments, business strategy, road mapping capabilities, and an entire ecosystem of certified road mapping, smart manufacturing road mapping professionals, several of which are here in the room today. But the topic at hand today is this notion of industrial data fabrics, and that's more on the technology side of what we've been focusing on. And I was thrilled to see every speaker today talk about interoperability, the importance of interoperability. That has been at the pinnacle of what our community has said is the technology challenge that we need to address going forward. I would say that the hallmark of Industry 3.0, I kind of entered the workforce, as you can tell based on the size of my forehead. I entered the workforce a few years ago, right as Industry 3.0 was getting started. The hallmark of Industry 3.0 was massive innovation, but unbridled innovation. Every plant floor, every enterprise today is littered with data silos and stovepipe architectures. Great vendors, great custom-built, homegrown solutions, but just littered all over the shop floor with very little approach or very little credence given to standards. Here in the US, standards haven't fared well. In Europe, I think they've done slightly better with standards than we have here for, I think, reasons we can understand and articulate, but standards haven't fared well here in the US. So as we, at the onset of Industry 4.0, we're here 10 years in, fairly much still focused on deploying stovepipe architectures and data silos, and that is not the path to the future we all envision. And so our privilege working with this community is to say, how can we take care of that? And I had 3 awesome slides to share those details with you. Obviously, that's probably not going to happen, but I will say this: imagine this picture, if you will. If there was a slide here that had a whole bunch of unstructured data sources, PLCs, machine tools, DCSs, historians, MES systems, it's all, we have to treat it all as unstructured data because there is no way, historically, there's been no way of imposing structure on that data because it's coming from disparate data sources and disparate data silos. The notion that we have to find some way to impose structure on that unstructured data through this notion of what we call information models or profiles, that's absolutely essential. And so to that end, we've built the infrastructure, a marketplace. We've got a community with our friends from the VDMA over in Europe, working to convene 800 machine builders and manufacturers to create these information models in standards-based way for the community, to give back to the community to be used. So we've got a marketplace. We've got hundreds of these information models that are free and available for everyone. And then our privilege is to work with great companies like HiByte and Inductive Automation and Rockwell and HiveMQ and OSIsoft / Aviva / Schneider and many other great vendors in this space to integrate with those information models in the marketplace, ingest them. And then the next step is how do we expose that context, that data in context to an API that not just the platform providers will provide, but that application developers can expect as a contract and discover those objects, discover that set of information models and create value on top of them in a way that's fully abstracted from the actual infrastructure. That is an issue, that is an initiative we began this past summer. We convened about 12 people, some of the brightest people in the world on this topic of manufacturing information data. And we began working based on the W3C, the World Wide Web Consortia for best practices for standards development. And we are halfway through the process to, in a fully open, transparent environment in GitHub. We've published this work. We've requested input from the entire world to say, what must this open API for smart manufacturing data look like so that platform providers can expose their content in this way and app developers can expect a consistent contract, a consistent open interface upon which they can build their apps. So this is, thank you, Conrad, this is the sort of what must be true for information through information models, the notion of moving that through a platform as an object-oriented, type-safe environment. These objects can be described and have relationships with one another and then discovered through an open standard API. Here is the SESME set of requirements for what must be true. If you're going to be an interoperability platform, you have to comply with these basic sets of requirements. And so from our standpoint, this is what an industrial data fabric is. We can know manufacturers, this is my privilege to work with Mike Tomasco from Fujifilm, the folks here from Coke Inc. and from Procter & Gamble and from Owens Corning. What must be true? We know we don't want any more data silos. We don't want any more stovepipe architectures. So if we have an interoperability platform, am I interoperable just within my ecosystem, or can I be interoperable within a broader community of application providers and platform providers? And so this idea, we believe, is absolutely critical. This is the new requirement. This is the standard. It's not a standard in the traditional sense of the word. This is the de facto standard for what must be true for manufacturers as they go to the marketplace and say, which vendors should I be investing in? So this is my final slide, my last point. This is the group that's working on this new smart manufacturing open API. I'm more than happy to publish well, you'll find it on our website, but there's a GitHub, a link to our GitHub where this is taking place. We've invited public comment. That's the phase we're at now. Well, in the second half of this year, for the first time ever, there will be a full launch for this open API. We'll have probably about a dozen vendors in the second half of this year developing against this API and sample code and everything else that's part of a traditional initiative like this for the entire community to engage in. And so that's a little bit about this part of what we do at SESME. I appreciate the privilege of being here with you and partnering with ARC and with Colin. And with that, I'll grab a seat.
Okay, so think you've introduced yourself, John. So next up, John Harrington, CEO and founder of HiByte.
And we might get some slides here as well. So welcome everyone to the panel. You know, Colin started off in talking about data and talking about all the different types of data, and he showed that great slide where there's all these different systems and different use cases. He talked about the challenge of governance and data quality. And of course, if we have lots of systems, we need to orchestrate data across them. If we're using AI, we need to today use whatever systems are available, but we also need to recognize that those systems are going to change. And if you're using a system today, you might as well expect that it will change probably in the next year, definitely in the next 5 years, because there's so much change and there's so much activity going on. We heard from all these great panelists, from Moderna, from Corning, from Coke. All of these companies need to move their data. They need to work on their data. HiByte is a software company that provides the infrastructure to do that. So we call the practice of moving and orchestrating and governing and providing high quality data, that's generally in the industry being termed data ops. HiByte provides a data ops platform. We work with all of these companies on the panel. We work with Sesame. We're partners with Hive. And all of these are customers of ours. So that's really what HiByte does, and I'm happy to talk with you. We have a booth next door in the pavilion, but happy to talk with you after that, and rather spend our time as a panel.
And our final panelist is Ravi from HiveMQ.
Okay. I didn't get any memo that I have to have slides, but I'm just going to talk about what HiveMQ does. And you saw what Moderna was showing there, right? So we're kind of like a very integral part of this data fabric and this whole distributed data computing space, which starts right at the edge and goes all the way to the enterprise or the cloud to enable all the AI, generative AI, agentic AI use cases. You need a robust data management solution that starts right from the edge. It's all about ensuring that you're able to break the data silos, bring the data from all of the different sources, which could be machines, which could be applications, which could be other systems that have some information. Think your CMMS system or your MES system having some information, ERP system. How can you all bring it together and create like this unified namespace or single source of truth? At the core, what we offer is like a highly scalable and highly reliable and secure data broker, as we call it, which is basically a publish subscribe way of consolidating information. We work with partners such as HiByte that provide that data ops aspect on top of that, which is kind of contextualizing the data. And then with that, we provide the scalable way of consolidating all of the data in one location, and that could then be used for all of your AI and ML and digital twin use cases. That, in short, is what HiveMQ is, and we built on top of the MQTT platform, which is an open source, which started in the late 90s in oil and gas and then spread to other industries as well. And we also have a booth, so if you want to know more about HiveMQ, please come and talk to us. Thank you.
Okay, and this afternoon at 4 o'clock, we'll have Devon Energy, actually probably going deeper than any of you did in terms of architecture. He's a real-time systems architect. So if you want to get a little bit deeper into how they've built their data fabric, that session this afternoon is going to feature more of the AI solutions. But I had 4 great customer speakers here, so I moved Devon to the afternoon. So for those that want a bit more technical, there'll be a little bit more in the afternoon. Okay, so I've got a couple of questions, but we've got Alex at the back of the room. He's got a couple of microphones. So if you've got questions, just when you stand up, tell us who you are, which company you're from, and then if you've got a specific panelist that you want to direct the question to, then please direct it at them as well. Perhaps let's start. There was a lot of discussion of unified namespace, right? But if you went and looked at my slide, I think part of the point I was making was that term has meaning, right, for us in the real-time domain and when we talk about time series data, et cetera. But at the other end of the spectrum, when we start talking about the enterprise systems, we use a different term, right? We talk about master data management and snowflakes and all sorts of weird terms, right? Can you talk a little bit more about how you deal with that magic word, contextualization? So how are you kind of bridging that gap when you have to have unified namespace blended with SAP data, or asset management is a transactional system, right? So very often that's a similar problem, right? You're not always dealing with real-time data there. So any volunteers to jump in there?
Is this on? Yes. The first thing that I always start conversations about unified namespace on is, if you break down the phrase, it's two words: unified and namespace. Any system that you have has its own namespace. Okay, in databases, it's the tables and the relationships across them, the columns in them. In MQTT, it's the topics and the data structures at each topic. In all of our different in S3 or Azure Blob, it's the files that are being placed there. So a namespace is just the description of the data that's there. To unify it is to standardize it and to apply a taxonomy and semantics to the data so that you can use it. Sesame has a lot of those definitions built in, and they've been working on that. So utilizing the standard ways of describing data and putting that into a namespace so that anyone in the company who needs access to that data can go to it and understand it, in my eyes, is a unified namespace. And we'll often say to people, look, if you want to build your entire corporate infrastructure on top of Snowflake or on top of Amazon or on top of Azure or Databricks or wherever, on top of Influx or even a SQL database, unify that namespace. That way anyone who needs access to that data can get it and can find it. A really powerful technique of implementing a unified namespace, especially in the OT world that we see today, is on top of MQTT. Because in the OT world, we have a number of applications that can pull that data out. A lot of our data is event-driven, and so it's very easy if you put it in the MQTT structure and then you allow your employees to get access to that. They've got a lot of open source and a lot of purchased applications that can pull that data down and they can immediately put it to use. And the idea is you don't know today what people are going to need tomorrow for data. So if you put it all there, then they can have access to it. And we see it across all industries, all manufacturing industries. And the power of that is the challenge that people have with most of their systems today is they're not flexible. So there was discussions earlier about how you got to go to 5 or 10 or 20 different applications to get access to data. Imagine if you could go to one. And imagine if you could go to that and the data was structured exactly as you needed it. You could immediately find what you need, pull that down, put it to use, and then tomorrow go there and ask a different question. And that's really the power of the unified namespace.
I'm going to ask Team John. You were itching to go next, and then you.
Yeah, so I would say to John Harrington, well said. The sources of data on the shop floor are inherently not unified. Every data silo and stovepipe architecture has its own namespace, and as you pointed out, John. So between there and the application, the AI model, the use case, where do you impose that structure? So you've got all your existing incumbent applications and all of tomorrow's applications to think about and plan for. Somehow you need to impose structure. And the idea of a unified namespace can be done within the four walls of your enterprise, but more likely you probably want to adopt, at least as a core, some of the core building blocks of standardized namespaces for the types of things, the types, the objects that are represented in your manufacturing operations, your assets, your processes, et cetera. So this notion that there's an open source set of these information models accessible for you as a starting point, the tools, open source free tools for you to extend those for your purposes, whether it's your unique IP or just unique requirements, and then impose that structure through one of these sort of certified interoperability platforms. That is absolutely essential to creating this notion of a unified namespace and the further you move from the plant into the enterprise and then to the supply chain, the more important it is that you actually think about this UNS concept beyond just your namespace. A truly unified namespace can actually be a huge value as you move this information from the four walls of your enterprise into the supply chain as well.
Ben, you were itching to say something, so.
Yeah, I'm a little bit passionate about this topic because, historically what happens is we compromise on unifying on one standard that everybody can agree on. And if you think about all the different purposes that people use information for, especially as you get into the really high value areas where we're making decisions about what to run on our assets, how to run our assets, how to optimize our assets, you end up in this really weird space where we're still sort of locked into this siloed tag name for a process tag, and we want to go put a bunch of context in this giant tag name and just move it from the shop floor to the top. I think the only way to get flexibility is to do what everybody else in the world's doing when it comes to managing data. Creating abstraction layers. You've got to create abstraction layers. I need to be able to come in and create a relationship as a consumer of data and build a relationship that this bit is connected to that bit that's in 3 different data sources, create a structure and how those items relate to each other to answer a question. Because if any of you were listening earlier, I talked about, the question that domain experts are trying to answer. That question determines the information they need. And so they ought to be able to ask questions of the data. Now, I agree, you can try to unify it as low down as you want, but I think you end up putting yourself in a box. In fact, I know you end up putting yourself in a box there. What you end up with is these really long tag names that aren't fit for purpose at use at the plant for the control systems where they're actually trying to run the process. They don't make any sense and they don't align with the finance data set that you're trying to compile at the end to figure out what doing some of these things are worth. I think you just have to get comfortable with the fact that you're going to have at least, at minimum, 3 different unified namespaces. One of them is, where did it come from? Like, can you put a structure on where the data came from, which plant, which subsystem, which line, which process area, as you move from the shop floor to the edge. Once I get it to the edge and I start to move it to the cloud, I then want to add another layer to it where I start aggregating information across multiple shop floor systems and say, these are all connected. Here's how they're all connected. So we know we're talking about the same physics and chemistry that's going on inside of the process on our assets. And then where that data gets stored is what you record in that second sort of body of context, right? So I have, where did it come from? Where did I put it? And then the real value and the real area you should focus on is, as I take that data out and make those relationships and make those connections with brute force to solve actual problems, capture that context, because that's the really valuable stuff that you're going to build on that's going to enable AI and next gen, who knows what's next. It's those turning the data into actionable insights, the connections based with the domain expertise. You don't want to keep going back to your experts to keep resorting and recontextualizing that data. So you need to give them the freedom to put whatever context they want on it. I should be able to go in there and build Ben's model for how I look at pumps and think about pump reliability. And David should be able to go in there and have a David's model for how I look at pumps and pumps reliability. And they should be completely decoupled and abstracted from how the data is stored and completely decoupled from how the data is sourced. So I don't think there is a unified namespace. I think there's a minimum 3. Right. And I think, there's a namespace for OT, there's a namespace for the cloud, and there's a namespace
Yeah, I mean, I always have the same reaction when people talk about the industrial metaverse, right? It's not going to be one metaverse. If it ever does materialize, it's going to be lots of metaverses, right?
I would like to propose an analogy, right? So, I mean, I think we talked about unified namespace, you talked about master data management.
Yep.
If you have a library, let's say it's like a grand, huge library, right? So you have to have some kind of like an indexing mechanism or a mechanism to get to your like different departments of the library, different kinds of books. So OT being like one set of department and IT being another set of department. Like you said, I mean, you might have to have different indexing mechanisms, maybe one unique for IT because it's like, that is where all the unique requirements of IT are laid out. and maybe there is something unique to OT, but then there is something that you need to pull in all the necessary information to make decisions. And that is this, this unified namespace that sits in the middle, that pulls in all the relevant information. You might have to have other indexing mechanisms for other purposes, but this is kind of like the framework that pulls in all of the things that you need to make business decisions. So,
I kind of have two other questions I want to get to in some shape or form, right? One is really more about, do you have to move all the data to a data lake to have success, right? And I guess the other one is similar vein. So I'm guessing the answer is no, but I want you all to react to that. I think the other question is, do you have to do it all at once, right? Because I think I can't remember who talked about, just take one use case or solve one problem at a time and solve the data problem incrementally, right? Obviously with a long-term vision and probably a long-term view on what the platform is and what the naming convention or taxonomy is, right? But I'm guessing you all have viewpoints on that.
Yeah, I'm going to start here. All the data, you can't do all the data. The beauty of today is that we can't do all the data, okay? We have PLCs that can handle hundreds of thousands of data points, and many of them have them. You have hundreds of those PLCs in an average US manufacturing factory or global manufacturing factory. You then can pull that data at millisecond rates if you really want to. If you do the math, you can't do all the data. Now, our historians don't have all the data. Someone went through and made a decision, these are the critical data points and these are the critical points at which I want to collect that data. It could be on change, but even when it's on change, if you have an analog signal, you have to define what is a change and what isn't a change. So there is no all the data. So I think you really have to start with what are the problems that you want to solve. And I think Ben talked about it earlier of starting with one, which goes to your second question, which is the beauty of systems today, as opposed to 25 years ago when we were implementing ERP systems and it had to be big bang and it took 3 years of prep and millions of dollars. The beauty of systems today is you can start small, you can solve one problem, you can build, and what our customers are finding is it's unbelievable how once you get going, it becomes a flywheel. Number one, people get access to data, they love it and they want more. Number two, it's easier to do use case number 2. It's easier to do use case number 5 and 10 and 20, because once you establish that base architecture and that base framework, it's fast to rip through it. And we have one customer who rolled out across 40 sites. After they had done the first site, they rolled out across 40 sites in 8 weeks. And it's unbelievable. Now, they had a focused use case, but they were performing predictive maintenance across each site, and they rolled it in 8 weeks because it's so fast and it's so agile. So I think the tools are out there, but you got to get started. And yes, I'm passionate about this one.
Sure. Yeah, if you want to be ambitious, like me in Moderna, is that, yes, we want all our data in a data lake. But then, like I've said, there's prioritization, right? So, because a lot of the data sources live in different, there's like system owners for the digital system. They would say, yeah, I want manufacturing data, but then you need the change control for that one. So for me, like I've said, since I'm in between GXP and non-GXPs, that like John said, you want to start small. You want to really prove that, hey, I can get data from a SQL database, from Pi, whatever, and then put it in a pilot wherein, I got everything from like a business digital system, from a manufacturing system, and if it's robust enough, then you can expand on it. Like I've said, you can be ambitious, you can have everything in a data lake. So for me, if for me myself, no boundaries basically. So that's it. It's up to you. It's really up to also the level, the domain expertise as well. So as long as you have all those domain expertise in-house, then you can do it. Otherwise, you can go externally and get support from your external vendors.
Josh, do you have anything on this one?
Yeah, ideally, yes, you have everything in a data lake. I think from a practical perspective, it's not possible. You just have to be intentional making the decision, yeah, I'm going to connect directly to this system because, and you've got to be intentional, acknowledging the fact that in 2 years that system might not be around, and now you've got to go re-architect with whatever you come in with afterwards. I think that's the biggest thing, is just being intentional about the decision and acknowledging what you're doing.
Maybe we're going to talk about different types of AI this afternoon. Devon will give a nice picture of many of the vendors' solutions, including Databricks and Aviva and Seek and a few other vendors in that picture. I think even a couple of you on the stage may be on his slide, but he does a nice job of kind of talking about all the pieces he has to use, right, to solve the particular set of use cases he's going after. We'll also talk a bit about causal AI and a Gen AI use case. But I'm very passionate about agents, maybe not because of hype, but because I think agents are going to allow us to distribute, along with the power that we're seeing coming for edge devices, right? Obviously, all the latest gen of CPUs and everything are now coming with NPUs and 40 to 100 tops of capability on the edge. So we're going to be able to do a lot more on the edge, whether it's data cleansing or conditioning or running actual training or inference models on the edge. Where I think agents really start to get interesting is we can now break down that problem, right, and have some of the work going on the edge. But have you thought about the data fabric in that context, right? And that was a bit behind my question. You know, the data lake, if you always have to do round trips to somehow get at that data, you've introduced more latency. Whereas what I think the opportunity is with agents running on the edge is going to be reduced latency and may need a distributed namespace, right? And so I'm sure you all have thoughts on that.
The usefulness of all of these tools, AI models, agents, is a direct function of how well your architecture, your infrastructure, and how thoughtfully it's been put together and designed. And so this flies fully at odds with the 4-decade dynamic of OT folks on the plant floor using whatever tool they have at their disposal, in many cases custom code, to solve whatever problem. It's the building twine and duct tape mentality. And so now to solve these massive problems and capitalize on this massive value opportunity, we have to change and become much, much more disciplined about our entire OT mindset in structuring, in OT engineering, in industrial data ops, and in working on strategic, with senior leadership support, working on strategic plans, strategies, architectures to facilitate these awesome capabilities that are coming our way, right? And so we're not going to do it with a data lake that has all this data, no context. We're not going to do that if the data doesn't move with the context through the enterprise and into the supply chain. That takes a whole new discipline, and that takes a village, right? That's the privilege we have as a community, as a consortia, to try to build these capabilities together with you, because it's something no one vendor wants to do to educate their customers. It's something that we have to work on as a community. So I'll stop at that.
Yeah, so just a fun thing. So data lake without any context becomes a data swamp, right? It's just a dumping ground for data, and then you're hoping that you find some use to it at some point, right? But to answer your question about how to optimize the data without by reducing latency and things like that, this is where I think like MQTT really scores, right? Because it is supposed to be exception driven. It is publish subscribe. So based on like real information that's available, that's what is brought into the broker, for example. And that's like building a unified namespace. Of course, there are multiple ways to build a unified namespace, but using an MQTT broker to do that provides these examples. You bring in the necessary information, you contextualize it, and then you use it. Not necessary to bring all of the information.
Yeah. Any of the customers here?
Yeah, I just have a comment. Again, I think I made it clear I oversimplify stuff. I think we're making a mountain out of a molehill a little bit here, because You know, if you go ask a subject matter expert, the smartest person in your organization that knows how to run a process unit, if you ask them this question, go home and do this. This is my default question when I meet a new subject matter expert with process or equipment expertise. I say to them, hey, I call you 2 o'clock in the morning because I'm down. And the unit that's taking me down is the one you're an expert in. What's the first 20 things you ask me about to help me solve this problem? Think about that for a second. And they start rattling off. You call me 2 o'clock in the morning, I'm gonna ask you, well, what color is it? How fast is it going? How hot is it, right? They have a list, and they go through this list. They don't even realize they're doing it, but they've built this entire mental model, right? It's real I, not AI. They got real I, that's a structure and a model, and they get to like 20 things, and then they tell you what it is. But if you say to them, hey, let's go build some software, what do you need to be able to look at a dashboard and diagnosis? They immediately come back with a list of 500 tags they want to see. And they're like, well, I need less than 500. If I can't have everything, I can't do it. But in reality, they can do a whole lot with 20 tags. So we're talking about all these giant, monstrous data structures here, right? And I think there's millions and millions of dollars in my organization, and I'm probably sure in all of yours, that is just sitting there ripe to be picked if I take specific problems that require turning data into insights and just go all the way from collect 20, 30, 40, 50 tags, relevant tags, land them with an expert, automate and instrument what they do with that information and what they feed back to the process. And you can just build an agent based on that data flow and that insight return. That's how this works. But it's like 20 or 30 tags. I'm not killing bandwidth. I don't need 7 edge devices with
any questions? Otherwise, I'll just keep asking them, right? But any questions from the floor? Andy, was there anybody? Sorry, Alex? No? We haven't triggered any questions, or you want to come up and ask them directly to the panel or the vendors afterwards? That's okay. Was there anyone else that wanted to add on to that? I didn't mean to cut you off. I just wanted to at least see if there was any questions out there. No? So what haven't we talked about that you should be thinking about? You kind of started hinting at a lot of the change management problems, right? And the people component, and to some extent, I think you're doing the same, Ben, right? Which is subject matter experts can really help you zero in on and prioritize what you need to do for each use case. Anything else, any other pearls of wisdom on somebody who's just getting started maybe, or is in that process of looking at what is that architecture that I need to put together?
Just based on what you just said and the session that Mark coordinated yesterday about agentic AI and how it enables manufacturing, right?
Yeah.
I think, again, going with people, process, technology as the 3 pillars of this ecosystem, technology is there. It is there, but it's not a magic pill, right? AI, don't tell your organization, hey, take this AI and like work some magic out. That's not going to happen. Unless you have like a particular use case, to your point, that you want to solve. And it has to be it has to be an actionable use case, potentially even a low-hanging use case that you can solve. And then build on it, build an ROI, build value proposition based on that, and then expand out to the rest of the organization. It's not going to succeed. And it also hinges on the people, because that they are going to be adopting it at the end of the day, right? You build the best sophisticated solution. If people are not there to adopt it, it's not going to go anywhere. And also the culture of the company and the management and the goals, all those need to be aligned for agentic AI, causal AI, and any AI that you are trying to put to succeed.
Okay. IT-OT convergence, is it a factor here? Or IT-OT-ET convergence? Or will they ever converge, or is it just they need to collaborate, right?
I remember I used to be the chairman of the board for MESA, the Manufacturing Enterprise Solutions Association. And in 2002, we were picking the topic for our annual meeting. We decided not to call it OT-IT convergence because that topic was tired in 2002. But here we are in 2025.
Yep.
2025, still struggling with it. And I think it has everything to do with what we're talking about here, right? The fact that you've got kind of an OT ecosystem servicing the plants and getting the engineers excited about what they can do with tools and systems and software on that machine, on that line, and you've got an entire enterprise IT ecosystem kind of driving top down and trying to standardize business processes and create sustainable strategies and architectures that are fully at odds with each other. And Both of those cultures and ecosystems kind of tear at the folks in the middle that are trying to get a corporate strategy, a corporate architecture kind of figured out. So I think this notion here, how do we build the OT engineering, the industrial data ops disciplines that are kind of aligned with how IT likes to work historically, but helping IT to become a little more operations friendly and flexible in terms of the speed and the agility at which work has to be done for OT. I think that this is the nexus where that OT-IT convergence can happen.
So that was a yes.
Yes.
Long-winded yes.
Yep. Yeah, from a technology standpoint, I think the data fabric is actually the point at which IT and OT are working together, and they're bringing things together because the data is spanning the OT to the IT divide, and it's not just OT to IT, it's also coming back down. So once you bring the data up to the cloud and people are using it in the cloud, oftentimes they want to push it back down to to the SCADA interface or the HMI interface, whether it's Ignition or whether it's Pi or anything else, and they want to present that in front of the operator so they can take action, or the mobile device. So from that perspective, that's happening. We also see, the successful projects, the teams are working together. All of our successful projects, we got people from both OT and IT. IT is bringing the firepower that OT is. Once they start to see how the technology works, they get enamored by and they get excited about, because the IT is doing things at such a greater scale, and between the cloud systems and the ability to orchestrate and the ability to orchestrate systems to the edge and the ability to containerize and all of that, it's just unbelievable in the practices that IT brings into the mix. So I think if you can get those two teams working together, you can get the technology working together, then that's where we're seeing magic.
Okay, I think we're starting to lose people. I know
We have a question over here, Colin.
Do you? Great. Oh no, Greg.
Well, not so much a question, but we got a late start in this session and we're running over again, and people are ready for lunch, so we're going to have to let them go.
I was just trying to wrap it up and then you interrupted, Greg.
I know. That's thanks, Colin.
Okay. So just want to thank the panel, and obviously Ben on the end from Owens Corning, David Moderna, Ravi with HiveMQ, John H with HiveByte, and then we have, I've got to remember, it's Coke Inc., Josh, and of course the legendary John Daig, right? From SESME. So give him a round of applause. Thanks.